All right, welcome back to the next video. We're moving right along here in Unit 3. Today we're going to be talking about the other big type of bonding, the other big type of ways that atoms can sort of connect together to make larger structures, and that is through covalent bonding, or the formation of covalent compounds. Okay. So the objective for today is pretty straightforward. You're going to be able to construct a covalent compound's structural formula. We'll talk about that based off of its chemical formula. Okay, so we'll talk about what a structural formula means here in just a moment. So as a quick review, what we've already talked about so far in this unit is ionic bonding and ionic compounds. Okay, so we have these things called ions, which are positive or negatively charged atoms. Okay, so when atoms lose or gain electrons, they end up with an overall positive or negative charge, and we call those things ions. And an ionic bond is not really a physical thing. It's just the electrostatic attraction between those ions. Okay, so the example that we looked at, I can't remember if this was the last video or 2 videos ago, maybe 3 videos ago at this point, was with sodium and chlorine. Okay, sodium has 1 valence electron, chlorine has 7, and you'll remember that both of these atoms are trying to achieve the 8 valence electron situation, the electron configuration of a noble gas. And so what happens here in a reaction between these two would be for chlorine to steal that electron away. What we end up with then is a positively charged sodium ion, a negatively charged chlorine ion, right, which has these valence electrons. And so these two are sort of stuck together. They're attracted towards one another, and that's called like ionic bonding. That's what that process is. The formula then for this ionic compound would be NaCl, right? They sort of exist in a 1-to-1 ratio, right? Because the overall formula has to be electrically neutral. And that's what we've worked on over the last couple days, right? We haven't necessarily drawn this process every single time, but fundamentally that's sort of what's going on if you were to imagine a reaction between 2 different elements, okay? So that is a good little review of ionic bonding. Now the other type of bonding, and that's what we've got to get into today, is called covalent bonding, all right? And this is different, okay? Covalent bonding, there is no transfer of electrons. Instead, covalent bonding is the chemical stability which arises due to the sharing of electrons. So instead of electrons like hopping ship and going from one atom to another, completely moving, instead they get shared between pairs of atoms. And there's a chemical stability that arises due to that. We're going to get into we're not really going to get into the details of exactly what this means in this course. It's complicated, okay? So once again, as always, if you would like to learn more about this stuff, you'll need to take AP Chemistry with me next year. So a couple other vocab words here that you're going to want to be aware of. A molecule is just a group of atoms that is covalently bonded together. So take a water molecule, right? That would be H2O, 2 hydrogens and 1 oxygen. That's like a molecule, okay? It's 1 unit of a covalent compound. The structural formula is different from a chemical formula, okay? A chemical formula would be something like this, H2O, okay? That's a chemical formula, all right? The structural formula illustrates the arrangement of the atoms in the molecule and how they're bonded together. So you've probably seen this before, okay? But this is the structural formula of water, where it's one way you could draw the structural formula. This is what we're going to be learning how to draw, okay? So we're going to be taking these chemical formulas and turning them into structural formulas, right? And we're going to be learning a few rules along the way. So we actually went through these examples previously in my sort of introduction video a couple of weeks ago. But I'm going to go through these examples again. And so now that we're sort of ready to dive into covalent bonding, we can pay a little bit more attention to some details here. So the way this works, you're going to be given a formula, and it's going to be your job to draw the structural formula, the arrangement of the atoms and how they are bonded together, how those covalent bonds arise. Okay, and so what you're going to want to start with is, drawing these elements out on a piece of paper, okay? Or if you have like a fancy app on your phone or a tablet or something where you can draw. Long story short, you are going to need to do some drawing, okay? So the assignments that we work on with this particular a topic are going to need to be done on your own piece of paper. The ionic bonding stuff we were able to do sort of in a Google Doc, but with the covalent bonding, since we are going to be doing some drawing and some sketching, I am going to need you to do this on your own piece of paper. Okay, so what I've done here is I've drawn my 1 carbon and my 4 hydrogens out like this. You might wonder, well, how do I know that they're arranged like this? It's hard to teach you rules about this. Generally speaking, hydrogens are not central atoms. Okay, carbon, if it's present in a compound, usually is a central atom, meaning it's sort of in the middle. Hydrogen tends to be peripheral or sort of around the edges or on the outside. So you'll pick up on some of these patterns, some of these sort of generalities as we go through some of these problems. Don't worry too much about it. You can always ask me, and you can always use the internet as a resource during class this year. So anyways, so I've drawn it like this, my carbon in the middle, my 4 hydrogens around the outside. And what I'm going to do is I'm going to label my valence electrons on each atom. Okay, the valence electrons. Remember, those are the number of electrons in the outermost energy level. Hydrogen each has 1. Notice how I'm sort of pointing that electron towards the carbon. Okay, I'm doing that intentionally. Carbon has 4 valence electrons. Okay, and notice how I'm sort of spread those out. Okay, I've done that intentionally as well. Covalent bonding is the sharing of electrons. Okay, and specifically, it's the sharing of electron pairs. So pairs of electrons sort of get together and exist between the 2 atoms, and in doing so, they give both atoms the sensation or the feeling that those electrons belong to them. So it's shared, right? So instead of the electron from hydrogen moving all the way over to the carbon, to where carbon gets all of them and hydrogen has none, that's not what happens. What happens is that these share together between the carbon and the hydrogen. So both the carbon and the hydrogen get to feel like they have both of these electrons. Okay, and if we repeat this little process here, let me draw that dot a little bit better there. If we repeat this process 4 times, these would be 4 covalent bonds. Okay, this is the structure we end up with. In a textbook or online, the way that this is represented is we replace these circled electrons with lines. Okay, so this line that I'm going to replace here, let me show you what I mean. I'm replacing those circled pairs of electrons with solid lines. Those lines represent 2 shared electrons, 1 from each partner. Okay, so you can see here that carbon has 4 covalent bonds connected to it. Okay, those lines each represent 2 shared electrons. So the carbon here feels like it has 8 electrons. And the hydrogens, each individual hydrogen has 1 covalent bond. Each hydrogen feels like it has 2 electrons. Okay? So we're going to do some more examples, but I wanted to show you something here first. There's something called the octet rule, and in a few cases, or in really just one case, we use something called the duet rule. Okay? The octet rule is more, it's the more commonly used term though. Okay? The octet rule is a guideline that's used when drawing structural formulas. Generally speaking, okay, and this was true with ionic bonding as well, okay, but in covalent bonding this also is the case. Generally speaking, atoms will share electrons so as to achieve the electron configuration of noble gas elements. So do you remember us talking about when ions how they gain or lose electrons, they're always trying to get to that 8 valence electron situation? Same story here with covalent bonding. Okay, noble gas elements have 8 valence electrons, and so hence this is called the octet rule, right? Oct means 8. Atoms are going to share electrons to achieve 8 valence electrons total. Okay, so that's what the octet rule is right there. Atoms are going to share electrons to achieve 8 valence electrons total. In the case of hydrogen specifically, okay, it's going to share electrons to achieve 2 valence electrons, okay? The reason is there actually is a noble gas that doesn't have 8 valence electrons, right? Helium has 2 valence electrons, and so that's kind of where the duet rule comes from, okay? Hydrogen, it's only got its 1 valence electron, so it can only share, one time, right? Because that in order to participate in a covalent bond, you need 1 electron to share with a partner. So hydrogen can only make 1 covalent bond, therefore it can only get to 2 total electrons, 2 valence electrons. So that's called the duet rule. But generally speaking, this concept is referred to as the octet rule, and all the other elements other than hydrogen are going to want to shoot for 8 valence electrons. Okay? All right. So the remainder of this video here is just going to be a few more examples of how covalent bonding works. Okay? So water, H2O. Once again, hydrogens are going to be peripheral. Okay, so I'm going to put those on the outside here, and I'm going to put oxygen in the center. I'm going to label my valence electrons. So each hydrogen gets 1, oxygen starts with 6, right? Once again, I'm getting that from the periodic table, right? My labeling on the periodic table tells me how many valence electrons these elements have. And what I'm going to do is I'm going to try to share electrons between the partners here to satisfy the octet rule and the duet rule, okay? I only have to worry about the duet rule if hydrogen is present. And for the other elements, okay, I'm going to try to follow the octet rule, okay? And there's actually a really simple way to do this, okay? I just like to connect the dots, okay? Because remember, each line represents 2 shared electrons, okay? So remember, we had that electron here and that electron here. By connecting the dots, I'm just sort of turning those 2 electrons into the shared bond, okay? So, and this sort of structure is what you're going to see online and in a textbook. Just be aware that each of these lines here represents 2 shared electrons, okay? And so then if I do some counting, let's say I focus on oxygen, okay? Oxygen has 2 electrons here, 2 electrons here. Those are referred to as lone pairs, okay? So this would be like 1 lone pair and a second lone pair. That's a total of 4, right? Plus 2 from this bond and 2 from this bond. That's another 4. Okay? So even though those electrons are shared in between, they count for both partners. So these 2 are going to count for oxygen and they're going to count for hydrogen. So oxygen has 8 valence electrons here, okay, due to the sharing. That's good. Okay, we want to follow the octet rule for every element except for hydrogen, right? And if I look at each of these hydrogens, each hydrogen has 1 covalent bond, right? 2 electrons. That's good, right? We want to follow the duet rule for hydrogen. If you satisfy the octet rule and the duet rule, you've done your job, and you've probably drawn the correct structural formula for your compound. Okay? All right, let's do another example. CO2, carbon dioxide. All right, so once again, carbon is usually the central atom if it's available. We don't have any hydrogens here. So I'm not sure exactly how to draw this, but like I said, carbon is usually the central atom if it is present. So let me put carbon there. Let me surround it by some oxygens. Okay, let me draw my valence electrons on here. So 6 for oxygen, 4 for carbon. Okay, now you might be wondering, this can get a little complicated, right? How do I know how many lines to connect, and you know, is there a systematic method that I can use to solve these problems? And the answer is kind of yes, okay? Think about it. Carbon has 4 valence electrons, and if we're going to get to 8 by sharing, carbon needs to share 4 times. Each time it shares, its total number of electrons goes up by 1, right? We started with 4, now we have 1, 2, 3, 4, 5, right? The line counts for 2, right? So 1, 2, 3, 4, 5. If I share again, now I'm at 6. 1, 2, 3, 4, 5, 6, right? And so the number of valence electrons you start with tells you how many bonds you're probably going to form, right? The number of valence electrons you start with gives you a clue as to how many bonds you're going to form. Carbon has 4 valence electrons to start. If it needs to get to 8, then you can do 8 minus 4 is equal to 4. It's going to need to form 4 bonds, okay? And we can look at how that principle applies to oxygen as well. Oxygen starts with 6 valence electrons. If it wants to get to 8, 8 minus 6 is 2. It's going to need to bond twice, share electrons twice, in order to get to 8 valence electrons. Let's just verify things here. Okay, let's look at this oxygen here. Okay, we've got this lone pair. Okay, this lone pair, so that's 4 plus 2 and 2, so another 4. This is equal to 8. That's good. Okay, it's going to be the same case over here because this is kind of symmetrical, right? If I look at the carbon, I have 4 bonds, each of which counts for 2, right? So 4 times 2 is equal to 8, right? That's good. All right, so we're wanting to satisfy the octet rule for every atom, every atom that's present in our compound. Okay. Now we can clean this up a little bit. Okay, this is very messy. We can clean this up a little bit, and this is probably what you would see in a textbook or online somewhere. Okay, these are referred to as double bonds or double covalent bonds. Sometimes you just need a single bond, sometimes a double bond occurs, sometimes a triple bond occurs, and that's what we're going to see in the next example. Okay, so I kind of spoiled it for you. We are going to see a triple bond. Let me write my 2 nitrogens here. Okay, nitrogen starts with 5 valence electrons. And so let's do that little trick, right? Starts with 5 valence electrons. In order to get to 8, that would be 8 minus 5 is 3, so it's going to need 3 bonds. And that's true, right? And we can see that by actually drawing the bonds here. Triple bond, each bond counts for 2 electrons. So if I look at just a single nitrogen, say this one right here, we have the lone pair, that's 2, plus 2 and 2 and 2, so plus 6. So 2 plus 6 is equal to 8. There we go. And that's going to be the same thing here, right, because this is a very symmetric looking situation. All right, so this right here is a triple covalent bond. Once again, we can kind of clean this up a little bit, make it look a bit nicer. It is important that you have your lone pairs drawn on any various atoms, right? If I did not include these lone pairs, right, then technically this is not the best way for me to draw this structural formula, right? It's not immediately apparent to me that nitrogen is actually obeying the octet rule. So it is important that you draw those lone pairs or those lone electrons, the unshared electrons on the different atoms that have them. Okay? All right, well that's it. That's 18 minutes, so that's plenty long. 4 examples worth. We'll do a couple more in class, and then you'll have an assignment where you're going to be doing this exact same thing. All right? Thanks a lot for watching.